Okay, so let's talk about an exponential relationship. So what is an exponential? What's wrong? Okay, exponential relationship. What does an exponential relationship look like? Sorry, I mean the actual function, the number part. Here's the power of x. Let's do a little bit better than that. Y equals a e to the kx. Okay, that's the exponential relationship that we all know and love. Okay, we got to know really well last term. So what I can do, let's see what happens if I take the ln of both sides. So log base e, the natural log. If I take the ln of y over here, I'm going to do the same on the other side. And I get the ln of a e to the kx. Now this is sort of a bit pointless, so I'm going to start breaking it up a bit. So I have ln of a. With my log laws, I add the ln of e to the kx. And now, with this second one, I can use the plog law and move the kx out the front, can't I? So I really have ln a plus kx ln e. Now what's ln e? 1. Okay. Now I have ln y equals ln a plus kx. Now can anyone sort of see what relationship I have between ln y and x? It's linear. I'll make it a little bit more obvious. I'm going to change ln y to big Y, and ln a I'll call big A. Okay, so I have this function big Y equals a plus kx. So I have a linear relationship. Think about it, mx plus c, or c plus mx. I have a linear relationship between ln y and x. Now what we can see how we've got one of our variables. So our original two variables were y and x. One of our variables is logged. One of our variables is just like that. It's just by, it's just x. So this is called a semi-log graph. Okay, so if we have a semi-log relationship that's linear, so in other words, we have a linear relationship between the log of y and x. We have a semi-log, which means we have an exponential. Exponential relationship. Now, at the moment, that might seem a little bit, what's the point of that? When we do an example, that'll hopefully become a bit clearer. Okay, I'm going to come back up the top here, and we're also going to talk about another type of function called power relationship. Now a power relationship, some people might know this, y equals ax to the n. Does that look a bit familiar? What could be a power relationship? Would a quadratic be a power relationship? Ax squared? Yeah? So a power relationship is basically where x is the base and we have some n. N could be a whole number, it could be 3, could be 2, it could be a decimal, it could be 1.8. Okay, it could be 0.72. Okay? But we have some value for n. I'm going to do the same sort of thing. I'm going to log both sides. So I'm going to go log y and I'm going to do log ax to the n. Now again, I'm going to break this up. Log a plus log x to the n, which is log a plus, now with my plug law, I'm going to bring the n down the front, so I have n log x. So I have this, what sort of relationship is that between the log of y and the log of x? I'll make it a little bit more obvious again. Y equals a, big A, plus n, big X. What sort of relationship is that?
Linear.
Linear, thank you. So we have a linear relationship log y and log x. So we have, it's the relationship between the logs of both variables. So we have a log-log, which means we have, if we have a log-log, we have a log-log is linear. We have a power relationship. Okay, so that's the explanation for what we're about to do. So I'm going to stop the recording here, and then I'm going to pick it up and we're going to do an example using this.